Growing degree days are valuable in estimating the growth and development of plants and insects leading up to and during the growing season. The basic concept is that development will only occur if the accumulation of temperatures exceeds some minimum development threshold. During winter and spring of 2022, OSU Extension in Fairfield County hosted a virtual Master Gardener training. On March 3rd, Ashley Kulhanek, OSU Extension Educator in Medina County, was featured presenter speaking on growing degree days and how growing degree days correlate to the phenology of plant and animal life. Listen in as we join Ashley as she begins her presentation.
So today we're going to talk about combining growing degree days and phenology. Now, you can use the raise your hand icon or type it into the chat, yes or no. Does anybody know what a growing degree day is or has heard of the term or heard of phenology? Because sometimes I find that it can be a hard concept to put into words. And so we have a lot of fun using examples to kind of get the point across, and we'll have a lot of examples today. But what we're really doing is we're going to be combining two different sciences and showing how we can use them together. So some people are saying that you've run across it from reading your manual. Absolutely. So at least you got a little primer there. So what is a growing degree day? So first, the name, I don't know who picked the name, but it's a little misleading. We're not counting number of days. We're actually counting a heat unit that accumulates over a 24-hour period. And they are cumulative. So you're going to add up the heat units each day so that you have a growing and growing number. So there's actually not a lot to do with days. It's really about that heat unit that's accumulating over 24 hours. So again, it is a measure of average heat accumulation above a base temperature. This is because we know that insects and plants both have temperature dependent development. So the warmer it is, the more development happens, the faster insects can grow. And so if we measure the temperature that's happening across a 24-hour span, we can actually use that as a measurement of how much development is happening in an insect or a plant. So the basic formula, and after I explain the formula, you will never have to do this yourself again. But it's the average daily temperature minus the base temperature. And that base temperature is the temperature at which things don't grow anymore or don't develop anymore under it. So sometimes it's freezing, sometimes it's 40, sometimes it's 50, but essentially when it gets cold, development slows down. So it's no use to us to count 80 degrees and say that there's been 80 growing degree days of development, because below 50, nothing's really happening. So we're really only looking at 30 degrees of development on average in a day. So here is an example. Let's say we want to take the average daily temperature. We'll say the maximum, probably this Saturday, is going to be 70 degrees. And let's say the minimum is 50. We make that average, that's 120. We divide by 2 to give our average, and we get 60. We subtract 50, again, that's our base temperature below which nothing's really developing, and we get 10 degree days. And so let's say this was Saturday, 10 growing degree days accumulated. And then you do it Sunday, and maybe there's 20 degree days now, plus Monday, maybe you get 30 degrees. And so it adds up over time. So I hope that makes sense. We're just taking the daily average, and this is the simplest form. There can be more complicated calculations done. Subtract the base, because when it's too cold, nothing's developing, and that gives us our growing degree days, or temperature accumulation units, developmental units, whatever you want to think of it as. And again, nobody really does this by hand, so you never have to do it yourself. We have a lot of really great websites and programs that do this for us based on weather stations. They use more complicated models, so it's a little more accurate using sine waves. And so OSU has a really great weather station network across Ohio. You can go to this website if you're so inclined, and you can use these weather stations to give you information about rainfall and humidity and soil temperatures and air temperature across the years. And if you click on one of the locations, you can pop up with a really detailed readout of things like growing degree days. So I've got my little laser pointer here. We've got our maximum and minimum air temperature. We've got precipitation. And then way over here, we have cumulative degree days and growing degree days. So sometimes CDD, cumulative degree days, and GDD, growing degree days, are interchangeable. GDD just means how many accumulated today. So you see here on November 16th, we actually had 4 growing degree days that accumulated. And then the CDD, or the cumulative, is sometimes they'll just have a cumulative average going on. It looks like that's not happening here on the website. So you would just look at GDD. So most pests and plants have a number of heat units they need to complete their development. So we can say that spongy moth egg hatch requires 192 accumulated growing degree days to hatch. And we need to start counting that temperature on January 1st. But fall webworm requires 867 growing degree days to hatch. And so each insect, and in a lot of cases plants, require a certain amount of heat accumulation or developmental time in order to hatch, molt, bloom, for leaf fall. And we can also think about this as, development for other things as well. So once we know what that X is, we can calculate temperatures and predict when those insects will come out, which is helpful when we're dealing with a pest, or when that plant is going to bloom, which is helpful when we're trying to plant our garden. And it's not perfect, so there are limitations. It assumes there is a perfectly linear relationship between temperature and development. So it's saying that the hotter it gets, the faster plants grow and the faster bugs are going to emerge. Well, what happens if I put a bug in the oven? Is it going to magically grow faster because I threw it up to 300 degrees Fahrenheit? No. So there is a point where it's too hot to handle, and we lose that correlation of hotter, faster. And so it does taper off up above 86, 90 degrees, where it's like, I'm not growing any faster. And there is a point where I'm just too hot, I'm going to die. And the same for those lower thresholds. If it's really, really cold, it doesn't matter if it's 32 degrees or if it's 45 degrees, nothing's happening. So it does have this S curve going on. Also, there are some other factors. Certain plant species are more responsive to day length than they are to temperature, especially some of those fall plant species. Some insects may be more responsive to periods of freezing. Elevation can affect how accurate that is. If you're taking temperature right next to a sidewalk or a building, it's going to be a lot warmer than it might be where the field station is taking weather readings out in the middle of a field. So there's microclimate effects. But all in all, it's a really great system for predicting insects. And we've done research to show how that can be a really beneficial tool in our toolbox for predicting pests or beneficial insects when they're going to emerge, as well as helping with plant bloom. But with all this math going on, it only has relevance when we know what the base temperature is, 50 degrees, 32 degrees. How cold is too cold? And we have a starting date to start counting from. So arbitrarily, if we're picking 50 degrees because it's pretty cold, And we're picking January 1st because that's the start of our calendar. But that means nothing to a bug or a seed. And so we use these because they work, but it's not based on anything other than it works. As well as, insects go through a period of diapause or cold hibernation between, December and February. And so if we start January 1st, nothing temperature-wise is really happening until we get going into spring anyway. So that is based in science. Insects halt their development, during the cold season in most species. But you can do science and experiments to see what those exact numbers are. So we could start counting from the exact day an insect goes into hibernation, which might be November 1st. We can find out what their physiological temperatures are. So insects might be able to develop above 30 degrees, or they might be tropical species and they don't develop well until it's 60 degrees. And so the base temperature is higher. This gets complicated, and we're master gardeners. I'm just, I'm not using this that complicated every day. So there are some studies out there, but they're for very few species that were like very, very serious pests that we needed to do better on timing. But we're not going to be asking you to know these or try to memorize them or use them in any way. But just understand that we're arbitrarily picking a date and a base temperature, and it could get more complicated from there if we wanted to. So what do we do then when we have a ton of insect species, a ton of plant species, and we want to use this tool, but that seems like a lot of work to try to figure out different base temperatures and count weather every day. We don't want to open up that website and look up the growing degree days all the time and remembering which bug and which plant needs what temperatures. That can be challenging, especially in a landscape where we have tons of different plants, or if it's a nursery and we've got a lot of different varieties growing. What can we do? And that's where phenology comes in, which is a separate but complementary science of studying seasonally recurring biological events and their relationship to the weather, which can be measured in growing degree days. So we put these two together, and it makes a really powerful tool. As a master gardener, you will hear growing degree days, GDD, and phenology often used interchangeably because of this great website tool that OSU has developed for us to use. And I'll show you that here in a little bit. That's combining growing degree days and phenology, and we'll see what that can do. So again, phenology is its own science for studying recurring biological events. Think migration, the color of leaves changing, flower bloom, insect emergence. So why add phenology? We know that plants and insects out in the environment are experiencing the same temperatures, weather, snowfall, and variations in temperature day to day. So they're in the same environment, sharing those highs and lows of Ohio weather outside. We know that plants are exposed to the same kinds of microclimates. So let's say I have a spirea outside, and underneath it in the soil, we might have some pests of spirea overwintering as eggs or as pupa. And so they're both out there getting the radiant heat off the side of my house. They're feeling the ups and downs of the temperature. And so they're developing at similar growing degree day rates because they're experiencing that same weather overall. Plants are big and showy. Insects can be hard to identify. So I observe plants easier than we can observe pests and insects in a lot of situations. And remember how I said that day length and elevation may factor into when things bloom or emerge. Well, if the plant is experiencing the same elevation and day length as the insect, they too are going to be having those biological events in the same sequence as your bugs will. It is the oldest science we know. Think back to the days of hunter-gatherer societies, where early man would have had to figure out when are certain foods like berries ripe to pick. How am I going to know to go out there and risk my life from my safe area to go, and then what if they're not ready? Well, I can observe what's going on around me. Maybe I'm waiting for some signal in the environment to say, berries are going to be ripening soon. How do I know when animals are going to be migrating across an area? Well, maybe I'm looking for a tree to be in bloom or other birds migrating by. That'll tell me that it might be a seasonal time for birds, game, and animals to hunt. Early agrarian societies used phenology to help when they started planting. Some things, for example, an old wives' tale goes, you want to wait to plant until oak leaves are the size of a mouse ear. And so I'm looking to my oak tree for when those leaves are just coming out, and then I'll say it's safe to plant. Because what happens if we plant too early and we get a killing frost, but we're not yet using thermometers, or we're not yet using other tools to help us predict? We're just using the environment around us to signal safe timing to plant and good timing to predict when to harvest or when to hunt. So I mentioned the oak leaf, the size of a squirrel's ear, plant potatoes when the leaves are the size of a cat's ear. Those are two examples from old farmers' almanacs that we can find that are indicators of phenology. So here they're using a plant as an indicator to tell us to do something else. So I like to share that Master Gardener volunteers and their activities are also a sort of phenology. When I start seeing tons of workshop flyers come out from different counties, that tells me spring is coming, because these are indicators that we're starting to think about gardening and get ready to get outside. And so even this is a kind of phenology in a funny way. It's also the oldest citizen science. So master gardeners, volunteers, homeowners for hobbies are keeping data that is actually phenological science. So for example, in Japan, we have phenology data dating back to the 9th century on when cherry blossoms bloom. So recording the dates and weather events around when cherry blossoms bloom is phenology. And we can study that data going back, centuries to tell us what was happening in the world weather-wise. It can tell us different kinds of storm events. And it can also tell us long-term what might be happening with our climate shifting. We also have data, for example, from England. The Marchand family has the longest family record of spring blooming from the 1700s. And so on their estate, they had journals kept. So you might have heard of nature journaling, where they would just record when different things, plants, animals started showing up in their yard, when things were blooming. And that record was kept through generations that we can now use to study the weather events and the climate of that region. We have used the journals of Henry David Thoreau and Aldo Leopold to study spring emergence here in, I'm hearing a crackling. Sounds like a bag of chips or something. Does anyone else hear that?
Yes.
Yeah, I think I went ahead and muted somebody that I think maybe.
No problem. I thought I was worried my headphones were staticky. All right.
No, I think you're good to go now.
So we have used records from other people who did keep nature journals. That's what tells us that spring is happening about 2 weeks earlier than it did in the 1800s. So what does it mean for your landscape to have growing degree days, to have phenology? Well, here's some quick examples. We can actually go to the National Phenology Network website and watch spring coming. So based on the bloom of lilacs and other plants, they can show you how fast spring is occurring northward across the country. It can help you to plan your garden. So using when blooming happens, which is phenology, we can make sure that our gardens have season-long interest, from buds to flowers to bark, and also what bugs, whether they be beneficial or pests, might be appearing and coming through the yard. So here's an example. A, B, C, D. Which happens first? A, upper left, this is a catalpa. B, upper right, this is a what? It's a maple in first bloom. C, this is a lilac. And D is Calorie Pear bloom. Which one happens first? You can unmute yourself, you can put it in the chat box. I've got to vote for A, which is the catalpa. Then I got B, 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 B. All right, so you are correct that B, the maple, happens first in our season. You may even be seeing some of those buds start to swell right now. And then you get these kind of stringy little flowers that pop out really, really early when it's still kind of cold. This is a silver maple, so that might also throw you off a little. 2, this is Calorie Pear, a horrible non-native invasive that no one should plant. But it's an early bloomer, and so you'll start seeing these white flowers popping up all over trees planted in neighborhoods, and also the invasive ones popping up in forest areas and disturbed areas next to freeways. Next will be our lilac, and then catalpa is a late season bloomer. And so this is a phenological sequence, 1, 2, 3, 4. And that can help me plant my yard to make sure I've got something blooming for the bees all year round or for interest all year round. And you can make these garden plans using an Excel sheet in different colors, or you can just scribble on a piece of paper. But you can either observe around you, like, hey, my neighbor has this great plant and it's blooming at a time of year that I don't have anything in bloom. Find out what it is and add it to your yard. Fill in the gaps. It'll help the bees, the butterflies, beneficial insects, and it'll keep your yard enjoyable. It'll also help ensure that we're feeding our insects and birds and other critters season round too. But importantly is that it'll help us with pest management timing. You guys may or may not have pest issues in your garden. You may not care about them. You might just let them be. That's great. When we're talking to nurseries and greenhouses and we're talking to farmers, pest management becomes a little more important because timing affects how effective our sprays are. It affects how much we have to use, and so it can affect the bottom line. And so spraying if we need to spray, or pruning if we need to prune, or hand crushing, scouting, the sooner we catch things, the more effective we will be. Because most of the time we don't notice it until the tree is covered in Japanese beetles and it's way too late. We don't notice it until the tree is covered with scale insects and the honeydew and the sooty mold is everywhere. And by then you can almost say, you know, this tree, you're going to have to wait till next season, or it's going to slowly die, depending on what the pest problem is. So timing is very important. So we did research to see, could phenology and growing degree days really help us to nail down when to be out looking for insects? This is some of the work I did. Master gardeners monitored first bloom of 16 woody shrubs. So first bloom is when the flowers just begin to open, and full bloom when 1 in 20 was not open. And so we wanted to see, could we use these to help predict insects? And so just like we said, We were monitoring which ones came first, second, and third every year. And we found that we could make a calendar based on when events happened, because they happened in the same order year to year. Doesn't matter if it got warmer quicker, the order that it came in was the same. So even though spring might be late or early, we might have freak snowstorms, it might get really cold, we might have a hurricane, whatever, the order it happens in doesn't change. And that was the research we were finding. Not only does it stay reliable year to year, it stays reliable location to location. So the sequence that plants and insects are emerging in Fairfield County is going to be the same sequence that happens in Medina. I might be a week later than what's happening down south, but it's going to happen in the same order. So using that garden data from across the state, we were able to support that in support of this website. So everybody, this is where it gets really fun for master gardeners. This website is actually out of date now because they moved the website. So what you want to do, if anyone has a piece of paper, I'll type it in the chat box too. You just want to Google GDD OSU, and that'll give you the website. And I'll show it to you when we do some examples. So this is our Phenology Calendar website. It also does growing degree days. So we're taking growing degrees and phenology and bringing them together. You just pick a date and you enter your zip code, and it will give you the blooming events for the landscape. We're missing a slide. Boop, boop, boop. Okay. I'll use this to show you the site real quick. Stop sharing. Okay. Share the website. So here's the website. It's weather.cfaes.osu.edu. Okay. And so we'll say, okay, what's happening on March 3rd, 2020 in my zip code. And I can see that even though it's been really, really cold here in Brunswick, Ohio, in Medina County, 17 growing degree days have accumulated this year already, starting January 1st. So we've had some days that have gotten above 50, where our average temperature has allowed 17 growing degree days to accumulate since January 1st. And you can see here comes the sequence of events to come. So the next things to happen will be silver maple will start to bloom at 34 growing degree days. You can see it up here in the right corner. Then cornelian cherry dogwood will bloom. Then silver maple will reach full bloom. Then our red maples will start to bloom. Alder and Forsythia. You see how it does that for you? So you could go in here at any time of year and you could check to see how many growing degree days have accumulated that day and get a representation of what phenological events in our plants are happening. So let me go back to the same day, a different year. Let's do 2020. In 2020, only 14 growing degree days had accumulated, but the same sequence of events is going to occur. Let's do. But in 2018, the same day in 2018, 59 growing degree days had already accumulated by this time 4 years ago. And we had already seen all the maples bloom and Forsythia by this day 4 years ago. So temperature accumulated faster because it warmed up sooner, but those events happened in the same order. that make sense to everybody? It can be a heady topic, I know. So we can use this sequence of events to help us predict insect bloom and upcoming plant events and insect emergence. I'd like to say that insects bloom. So we use the plants to predict other events that are not easily seen. I can see Forsythia, that big yellow ugly shrub out there, the first thing that blooms everywhere. Yeah, that's easily visible. But you know it's not easy to see? Calico scale, Fletcher scale, insects that burrow into trees, crawler stages. These are tiny bugs that have a big impact. So I'd rather keep an eye out for plants that then tell me this bug is on the loose. We already do this for some bigger things. So we use red buckeye bloom as an indicator of when hummingbirds are going to migrate. So when the red buckeye is in bloom, hang up your bird feeders for hummingbirds. That's a big indicator of when to be on the lookout. So we use those instead of guessing. So here's some other examples from the website. This is May 15th, 2016 for Columbus. On May 16th, we had, or 15th rather, it was 552 growing degree days in 2012, but it was 339 growing degree days in 2019. So on the same day, they were at completely different places in the phenology sequence of blooming and insect emergence. So you see, if I was looking for lilac borer adult emergence, I could say if you go out scouting on May 15th, that's a good time to catch it. But that only flew in 2019. If I had been out there searching for lilac borer in 2012, it would have been emerged and gone by then. It probably would have laid its eggs already, died off, and we wouldn't have had time to catch the larva before they burrowed into the lilac. And so it's more important to catch the event than it is to pick a date. Like, oh, we always want to plant our tomatoes on Memorial Day. Well, that's a good rule of thumb. But sometimes we can use actual temperature development to tell us when things are actually ready to bloom and emerge. So here's another example from 2017 and 2019. We're seeing that there were 83 growing degree days on March 9th in 2017, but in 2019, only 15 had emerged. And so you can see that it was very cold in 2019, but it was very warm in 2017. So this makes the biggest impact in early spring when everything's starting to warm up. And then it levels out once we get into the later season and it's just warm all the time. And you can see that the Forsythia had already bloomed in 2017, but we were still probably a couple weeks away from having it bloom in 2019. So it's a great way to compare years as well. A great tool then is that they have the full list you can download. So when you go on this website, there's a button that says full calendar, and it pulls up the whole list of what's going to happen and in what order. You can see in black that it tells me where we are on the date I selected. So this was on March 9th, 2017. And it shows you everything that did happen and everything that's going to happen in order based on growing degree days. So it brought the phenological event and the math of the temperature together to make this calendar. And so you can go down and look for what plants do you have? What bug are you looking for? And keep track of when things are going to occur. And we can use it then to predict our pests. So let's put it to use. Here's some examples. Calico Scale is a non-native invasive insect. Scale insects, I know you haven't had entomology yet. They're small, very, very tiny insects. They have piercing, sucking mouth parts that they stab into the bark and twigs of woody shrubs and perennials and annuals, and they suck out phloem, that sugary sap of the tree. And so out the back end comes honeydew. It's a sticky liquid, concentrated, kind of like syrup. And they pull those nutrients out of the tree. And over time, that feeding stresses out the tree and the tree can die. So this is a nasty little guy. It's considered a soft scale, so it's puffy. If you find it, it's easy to squish with your hands. But because they are well camouflaged and they go unnoticed, the populations can explode. They lay a lot of eggs. And they feed on a lot of trees. So we go from buckeye to hawthorn, honey locust, magnolia, sweet gum, tulip, poplar, and on and on. It'll feed on most of our woody shrubs and trees. And you can see here, this branch is absolutely covered with Calico Scale. All these little bumps are scale insects feeding on this honey locust. And it weakens and makes the tree susceptible to disease, environmental stresses, and other insect pests. So this is a honey locust that's infected by Calico Scale in 2014. And this is the same tree in 2015. So you can see the impact that these insects make in just one season. So I need to scout for them, find them, and kill them before they affect my trees. So we know that we have to target the summer crawlers, which means just after eggs hatch, I have to spray for Calico Scale because they make this really great waxy coating. You can see this kind of zebra striping happening here in the photo. That's a waxy coat that protects the insect underneath. So we have to target egg hatch. Well, they're teeny, teeny, tiny. You can see this is a honey locust. So each one of these leaves is a leaflet, probably 2 centimeters long. And each one of these yellow dots is a crawler, a just hatched scale, very small. And so they're not easy to see if I'm just walking by a tree, especially if it's a full grown tree. But we know that eggs hatch at 740 growing degree days. So you could do the math. You could go to the weather website, or you could use our growing degree calendar to find out what else is happening at 740 growing degree days. So what is it? Let's find out. So Calico Scale egg hatch. Around it, we can see that fuzzy deutzia is in bloom. Red Prince Weigella is in full bloom. Northern Catalpa has just bloomed. These are all indicator species that I can use to say, better get out there and look for scale. Catalpa is very big and showy. It's our only native world tree, has those big long beans, orchid-like flowers. I can see that tree. I can identify it on the road. I don't have one in my own yard, but there's a bunch around me. So if I find Northern Catalpa is starting to bloom, I'm going to start scouting for Calico Scale. Fuzzy deutzia is an ornamental, so it might not be as easy to find, but if you happen to have it or know someone that has it, it's a great option for like a fence line. It makes a really good, dense, big, showy, grows well into a fence shape or property line border. Weigella is a really common one that's in a lot of landscapes. It was very popular. It's a hummingbird favorite. So a lot of people like kind of that red trumpet flower. So these are ones that are easy to find, or if you want to add them to your landscape, that's a great option too. So these are indicators for that scale. Then I can know I need to go out and monitor, scout, and I can treat if I need to. Eastern tent caterpillar. We have a lot of tent caterpillars in Ohio. The eastern tent is an early one and it has boom and bust years. Some years you don't even notice it. Other years, it can defoliate a forest. And again, that defoliation is a stressor for the tree. So here you can see all this spider webbing. It looks like a spider web. That's actually the silk that the caterpillars are exuding in their tents. And it looks like it's October and Halloween. This is early spring and it's been defoliated. For some reason, it's not advancing the slide. There we go. So those are some great examples for how you can use the growing degree day to predict when these are coming out, because we want to catch them early. We want to use insecticides the proper way, so the smallest dose. We want to attack the target stage. Most insecticides are more effective on baby insects than they are on full-grown insects. They can help us to prune. If I caught those tent caterpillars early enough, I could have just pruned them out and I wouldn't have to worry about them having spread to the whole canopy and making all their webbing all over the place. And so it helps us to time other cultural practices so we don't have to necessarily use chemicals either. So here's Eastern tent caterpillar egg hatch. And looky here, border Forsythia, one of the first bright yellow shrubs that blooms in the season. You can go out and look for these tiny hatched caterpillars. You can see them here in the picture on the right, very small, but clustered together. If I find them now, when they're the size of a penny, I can prune that branch out, done. No problem, no chemicals, no damage, ta-da. But if you don't know to look for them, watch for the border Forsythia. That'll tell you maybe it's time to start looking for bugs, especially if you've had a problem with them in the past. If you have a nice, well-rounded yard with good predators and you haven't had a lot of pest issues in the past, you might not need to. But for areas where we know we have issues, this is really helpful. So Forsythia is a great indicator of both spring and some pest activity. Mew mew, a beautiful kitty had to share. So sometimes Forsythia can be a little unwieldy. I always have to chop it back. And remember, you have to prune it right after it finishes blooming. Otherwise, you'll prune off next year's flower buds. And I'm sure you've had years where it's been so cold or so snowy that frost will just rip through these buds and they might not bloom at all. So that's one of the downfalls of Forsythias. There's some years when it doesn't bloom because it's got so much frost damage. How about spider mites? You probably think anytime a spruce, an arborvitae, or a pine dies, it's got to be mites because they're nefarious. They are hard to see, they're hard to catch, and usually by the time we have damage, if you spray for them, they're already gone, and you're just killing all the good stuff, all the good bugs that are there. So teeny, 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 teeny. And their feeding damage causes this stippling. So it looks like something's just stabbed into the leaf or the needle or the awls here, and they leave this bronzy yellowish color because they've pulled out the chlorophyll from the tissues. It'll cause browning of needles and leaves from the inside out. But by the time it's all brown and we're like, oh, something's wrong here, they've already died off and been eaten and moved on. And so then we spray and we spray and we spray, but it's too late. The plant is already dead and damaged. And that's a really bad thing to have happen to an evergreen that's not going to replace its needles. So we need to get on top of our spruce spider mites and other mites. I mentioned spruce and arborvitae, but it also affects juniper, yew, hemlock, firs. So this is a common sight, unfortunately, for a lot of our Ohio evergreens. Could be a disease, could be mites, could be something else. This is one where you really want to diagnose it properly. But if we're dealing with mites, we have to treat appropriately and scout for them.
Hey,
So what are we
Ashley,
looking? Yeah.
We have a question in the chat.
Yes.
What's the true name for bagworms that appear every 3 or 4 years on arborvitae?
Okay. I have bagworms in here. I don't know the scientific name off my memory, but yes, we'll get to the bagworms. So spruce spider mite, we're looking for serviceberry to be in bloom. Serviceberry is also a great replacement for Calorie Pear. It blooms at the same time, same kind of white flowers, early spring. So you can also use Calorie Pear as an indicator too. You can see right here underneath the spruce spider mite, the Calorie Pear will be in full bloom right after the egg hatch. Okay, so gypsy moth is no longer called gypsy moth. It is now called spongy moth. So that's a new one. Let's see, I know I only have a little bit of time left, so I'll just skip ahead to our bagworms. They should be in here. Oh no, I think I took it out. Oh, nope, there it is, bagworm. We'll start here. Okay. So, bagworm. So, when we're looking for bagworms, here's the official name for it. I can't pronounce Latin. So if you want to write that down, Thyrodopteryx ephemeriformis, I believe is how we do that. So that's the true name for bagworm, but it's going to be right there next to 2-spotted spider mite. So a 2-for-1 scouting benefit. You could look around for Japanese tree lilac, which is a great popular street tree right now. Spirea bloom, and again, that northern catalpa that is really showy. They're all going to happen right around when those eggs hatch. The benefit of finding bagworm early is that when they're very, very tiny caterpillars that just hatch and they start feeding, that's when they are most susceptible to BT, or Bacillus thuringiensis, the organic insecticide that kills only lepidopteran caterpillars. So it only kills butterfly caterpillars and moth caterpillars. It doesn't affect beetles or bees or flies or praying mantises. It only kills those caterpillars. And so if you spray this on an arborvitae that has teeny bagworm babies on it, no other real butterfly caterpillars are going to be found on arborvitae or spruce in that way. And so you can use an organic option that's based on a bacteria. It's very effective, but it only works if you catch the tiny babies. And so when they're little, they actually wear like a dunce cap. And so you'll see this little tiny caterpillar walking around with a triangular hat on its head. And that's the stage right before it builds the big cocoon. It starts building a little hat first. And that's how you can identify them and treat them very easily. So there's Spirea and Catalpa as 2 of our indicators for bagworm or 2-spotted spider mite, as well as the Japanese tree lilac, which are showing up more and more in developments of street trees. So as you can see, I can do this all day. Here's pine scale, emerald ash borer. I'm sure you've all had a dead ash tree in your yard. This one has been studied so much that we can actually say that the best time to spray for them is when black locust is in bloom. So not just when to look for them, but when to treat them. And then also some of our invasive pests that we don't have yet in our county, but if we're worried about it showing up, this is a great time to scout for it to make sure we haven't gotten it. So this is Asian longhorn beetle. They're working on phenology and growing degree numbers for the new spotted lanternfly. And these can be very helpful for us to predict them keep an eye out for them, scout, and report back to your extension office or the Department of Ag if you find anything. And then finally, I just want to put in a plug for doing it yourself. So we have this great long list of ornamental plants and insects of concern, but not every insect is on there, not every plant is on there. So you can create your own little calendar as well. So we talked about some of those early families, those 9th century data points on cherry in Japan. Those are all from individual humans, people just out and about nature journaling. So you could keep track of what things are in your yard, when they bloom, and then go to the website and find out how many growing degree days are happening today. And you could write down that that was the growing degree day you saw your particular variety in bloom. If you have certain kinds of trees or shrubs that you love, that you're all over your landscape but aren't in the calendar, you can still collect that information and in your head, insert them into that calendar, or you can print it out and add a sticky note that, you know, my paperbark maple that I love is going to go right here in this calendar, in this sequence. If there's a certain beneficial insect you like, so that focused a lot on pests, but what if I really, really want to go out and start looking for the wool carder bee? And the wool carder bee comes out in late August. It's not an early season bee, but I can keep an eye out for when I see this is in bloom. I bet I'll find some of my favorite bugs that I like to photograph or catch, or butterflies I want to see. And I can keep track of those in a journal too. Our pollinator specialist, Denise Ellsworth, she often teaches nature journaling classes to kind of get you in the rhythm of making these observations and reporting them and writing them down. You could also reconstruct a calendar from your own photos. So if you took this photo and you go back and you say, when did I post it to Facebook? When did the phone tell me I took this picture? And you can then look back and say, when are things blooming? When was this bee out? What time of year was this? Based on when that picture was taken or what's blooming around it. So here, for example, my Medina County parks, they were posting when skunk cabbage was emerging and blooming. And so I can use February 11th and March 6th as data points. I don't remember what year these were taken, but then I could go back and say how many growing degree days were on the 11th and the 6th. And I could use that for skunk cabbage if I like to be out in the wilderness and catching ephemeral wildflowers, some of those rare plants that are only there and gone in a second. How do we predict when those are going to be out and I need to be at the gorge, at the park, in the woods to see them? So here again, colt's foot is another example. We also have the Buckeye Yard and Garden online. So this is another form of phenology. You should all sign up for this. Carrie, get them all signed up for this. And then we try to post things as they're happening too. And so if you weren't tracking the growing degree days, you could go on our Beagle, the Buckeye Yard and Garden, and it says, hey, warning, June 7th, we found the first instar of Calico Scale. He saw it. I need to look around my area now too. So Joe here, he's in Cincinnati, and I know I have a couple days before it happens in Medina County. So you can use newsletters as another form of indicator for you to go out and scout. And there again are those eastern tent caterpillars. So we've taken two forms of science, weather and development in the growing degree day calculation. We've taken phenology, these recurring events that keep happening in the same sequence year after year. We've put them together as a tool for you to help predict and plan your garden and your pests, your beneficials, when you want to be out walking around, bird watching, butterfly watching, bee watching, whatever your needs are. Hopefully degree days and phenology can help you with that. So with that, I want to thank you. Again, you can either scan this barcode or visit go.osu.edu/CHXY, and that will be my survey for my program.